L'Hopital's rule. That fuzzy little friend you first met in Calc 2. We shall first review the definition of L'Hopital's rule. Let S signify A, the right-hand side of A, the left-hand side of A, positive infinity or negative infinity where A is an element of the real numbers, and suppose that f and g are differentiable functions. Denote the limit of the derivative of f of x divided by the derivative of g of x as x goes to s as L. If the limit of f of x as x goes to s and the limit of g of x as x goes to s equals 0, or if the limit of the absolute value of g of x as x goes to s is positive infinity, then the limit of f of x divided by g of x also equals L. In other words, if the evaluation of the limit of f of x divided by g of x yields an indeterminate, L'Hopital's rule is useful. Examples of indeterminates include indeterminate ratios such as infinity divided by infinity or 0 divided by 0, indeterminate products such as infinity times 0, indeterminate differences such as infinity minus infinity, or indeterminate powers such as infinity to the 0 power. If the limit yields an indeterminate product, difference, or power, rewrite it so it yields an indeterminate ratio. We will illustrate some of the properties of L'Hopital's rule using several examples. Example 1. Find the limit of sine of x divided by x as x goes to 0. Using L'Hopital's rule we take the derivative of the numerator sine of x and denominator x. Evaluating the resulting limit cosine of x divided by 1 as x goes to 0 yields a result of 1. Therefore the limit of sine of x divided by x as x goes to 0 is 1. We shall now consider a second example. Find the limit of x squared divided by e to the 3x as x goes to infinity. Since the limit of x squared as x goes to infinity is infinity and the limit of e to the 3x as x goes to infinity is infinity, we have an indeterminate ratio, and L'Hopital's rule should prove useful in evaluating the limit. Using L'Hopital's rule we take the derivative of the numerator x squared and denominator e to the 3x. The resulting limit 2x divided by 3e to the 3x as x goes to infinity yields another indeterminate ratio. Employing L'Hopital's rule a second time yields the limit of 2 divided by 9e to the 3x as x goes to infinity. Evaluating this limit yields a result of 0. Therefore the limit of x squared divided by e to the 3x as x goes to infinity is 0. A third example will illustrate a mistake commonly made by eager young calculus students. Find the right-hand limit of the log of x divided by x as x goes to 0. Using L'Hopital's rule we take the derivative of the numerator log of x and denominator x. Evaluating the resulting right-hand limit 1 divided by x divided by 1 as x goes to 0 yields a result of positive infinity. Therefore the right-hand limit of the log of x divided by x as x goes to 0 is positive infinity. Stop. Let back up the train. L'Hopital's rule states that the limit of the derivative of f of x divided by the derivative of g of x as x goes to s and the limit of f of x divided by g of x as x goes to s are equal to each other, right? Close, but we have forgotten to check the coveted assumptions. L'Hopital's rule only holds if the limit of f of x as x goes to s and the limit of g of x as x goes to s equals 0, or if the limit of the absolute value of g of x as x goes to s is positive infinity. Examining the graph of the log of x divided by x illustrates that the right-hand limit of the log of x divided by x as x goes to 0 is not positive infinity as L'Hopital's rule would lead students to believe, but is actually negative infinity as the graph illustrates. Often functions need to be massaged, as Dr. DeLong would say, so that L'Hopital's rule can be employed. Example 4 will illustrate how this is done. Find the limit of the quantity 1 plus 1 divided by x to the x power as x goes to infinity. An initial evaluation of this limit yields an indeterminate of the form 1 raised to infinity. Let f of x equal the quantity 1 plus 1 divided by x to the x power. Taking the limit as x goes to infinity of the natural log of f of x yields the result shown. We then bring the x power out front and rewrite the result as a quotient with 1 divided by x as the denominator. Thus the limit of the natural log of f of x as x goes to infinity is as shown. Evaluating the limit yields an indeterminate of the form 0 divided by 0, and thus L'Hopital's rule can be used and the function has been massaged appropriately. Using L'Hopital's rule we take the derivative of the numerator and the denominator. Simplify. And then evaluate the limit. Therefore the limit of the quantity 1 plus 1 divided by x to the x power, as x goes to infinity, is 1. As long as the function can be massaged to yield an indeterminate ratio, L'Hopital's rule can be used. I hope that you have enjoyed this trip down memory lane exploring L'Hopital's rule. Congratulations to the DMS on successfully completing advanced calculus.